Hey guys, welcome to another episode of Tradecraft Tuesday, where we spend every Tuesday exposing hacker tradecraft, talking about what the newest techniques are in the wild, what authors are doing of malware, and what we can do to stop it. Took a little break last week, coming back this week with an action-packed episode focusing on compromising Amazon Web Services. What's neat about AWS or cloud services in general is a lot of folks think about a compromise on a host-by-host basis. But when you actually get access to like the master cloud account, you can do a whole lot more pwnage, and it might even be harder to get somebody out. Like we do every week, we jump into an episode with news, and this week's been kind of jam-packed with news. Before we get into that, I want to remind everybody that we do have a live chat option through Slack. We just tweeted a link from our @TradeCraft2s account on Twitter for you to be able to get your invite to Slack if you're not there already. On one last note, Chris and I love to hear your guys' feedback. We've got some excellent stuff over the last week, and this is actually a result of you guys saying, hey, we want to know more about this. How would you do it? How would you catch somebody? With that said, Chris, you want to jump into the news?
Yeah. So the hack that everybody would love, right, is being able to just make an ATM spew money. So, what better way to turn your hack into profit, right? So there were some thieves in Taiwan who have done exactly this. No one's really sure yet exactly how they did it. It looks like the police reports say they connected a device, whatever that means, and then basically the ATM spewed out a bunch of money. And it looks like they might have done it to a couple ATMs, but it looks like they got away with like $2 million. So
$2 million in ATMs total?
Yeah, I don't know. It must have been a bunch of ATMs, or maybe in Japan they just hold a lot of money. I'm not really sure.
Because I've seen a lot of the Russian hacks where they're like malware augmented or somebody gets access to the administrator terminal.
Yeah.
But boy, that's a boatload of cash from an ATM.
Yeah, that's what I thought too. So I don't know. So, but one thing they did say is they were not, or it appears that they were not using like stolen ATM cards. So I don't know. Maybe this is some sort of hack similar to what Barnaby Jack did in 2010. So maybe more details will come out of this.
Yeah, that's exciting. I noticed this week it's also been pretty crowded in ransomware. Always new variant of ransomware, whether it's here's a current version that's not living up to its encryption standards, or here's somebody who ran off with more documents from a hospital. This week, I think one of the new techniques I saw though was using Google Docs, right? It was something about storing the encryption keys in Google Docs.
Yeah. So the details were a little bit scant on this one, but it looks like the when they encrypt your hard drive or whatever, they would like upload the keys to some Google Doc, which is sort of interesting, although it's not very good because all somebody has to do is notify Google, and they'll like lock the document out or whatever. So interesting nonetheless, though. This is the first case I've seen of someone like using a Google Doc like that. So I wouldn't be surprised if you start seeing more people use it for like command and control type stuff. We've seen other things like that with like forum posts or things on the blockchain. So, it's just another place, because enterprises aren't going to be blocking Google Docs. So, malware is going to be able to reach out and touch it.
Yeah, I think that reputation is definitely what they were going, right? If you have any organization that does any business over Google Drive is going to allow you to access that. So I think that's a definite interesting way to get around that. Hey, if we can block the exchange of the encryption key, then maybe this ransomware won't be effective. So I have to imagine that's what they were going for there.
Yeah.
In addition, talking about honing enterprise, I think it was the AMI remote administration tool. So this is a legit remote administration tool, not the typical rats that we talk about that are being weaponized for nefarious reasons. But what was neat about it is the attackers looked like they actually compromised the infrastructure of AMI. I believe it was modified some PHP scripts. So when the AMI installer was downloaded, it was bundled with, I think it was at least the lurk malware as well was installed.
Yeah. So, look out for what you're downloading. Make sure it's signed, yeah.
Now, it's an elegant way to target system administrators. If you want to make sure that you're going after the folks that likely have creds, why not backdoor the software that they're going for?
Right. Right. So yeah, I don't know.
And I mean, that's kind of an interesting transition, though, to our AWS conversation, right? So to be clear, we're picking up on somebody else's research here. So I guess it's worth starting off by thanking Daniel Grislick. He's managed to put a couple interesting blogs out, just talking about, hey, here's what compromising a web service is all about. Specifically, he's talking about Amazon AWS in his blogs. But more often than not, people will say, oh, here's the compromise, but what do you do afterwards? So he had a great follow-up blog as well that talked about what you could do, how could you persist in AWS, etc. So Chris and I are going to break that down today. We're going to kind of take a couple steps back and say, hey, what does AWS pwnage look like over the last couple years? Because this isn't a new conversation. However, the techniques and how criminals or hackers in general are using compromised AWS credentials has definitely changed up, at least in the last 5 years.
Yeah. Yeah. So let's start at the beginning, and for anybody who's not familiar, what is AWS? So AWS is
at least in the last 5 years
provided by Amazon. What's that?
Oh, so that was actually me clicking on a tab that had my voice playing as well. So let's move on.
All right, moving on. Live show. Here we go. So AWS is basically shortened version of Amazon Web Services. So it's basically a service provided by Amazon where companies and developers can spin up cloud infrastructure quickly and easily. And there's actually a lot of sites that use this. For anybody familiar with Reddit was, I'm not sure if it still is, but when they started and for a long time, they were entirely based on AWS. So they didn't own any of their servers. They were entirely hosted on AWS. It allows them to scale up, with one click or via some trigger. You can spawn more servers to handle larger loads of traffic. They basically have everything there that any company would want to set up, like a whole website. They provide databases, load balancing, storage, pretty much everything that you could want. And so over the years, attackers have kind of realized that, like, hey, look, there's all this stuff there, and a lot of people are interacting with it programmatically. What if I could steal their creds? I could do stuff too, and now I can start to get the power of being able to run a lot of servers, and somebody else is going to end up with a bill. So that's kind of where a lot of this spawned. Attackers realized they could use this infrastructure as well.
So I'm thinking right away, Chris, maybe it was the early days of Bitcoin, I think was the first time that it actually dawned on me, which that's even still late in the game, that I think some AWS compromises were going. But I recall folks either pasting, like you mentioned, pasting something to GitHub or losing their private key, somebody stumbling onto that private key or posting it to Pastebin, and then people using their private keys to just spin up hundreds of VMs to start mining.
Yep.
Is that some of your first reference, or do you have recollection of anything going on before that?
So it really started out spammers. So spammers needed to be able to send out emails. A lot of the open relays that existed in the early 2000s for just relaying email, those were starting to close down. They weren't open anymore. So spammers found that it was super easy to just spin up an Amazon instance and just send out a ton of emails just from those. And, they did this. And basically the result of it is that almost all of the entire IP address range for AWS is on all of the spam blacklists. So it's interesting because it makes legitimate uses harder because they can't directly send email from their servers. They have to use other third-party services that have different servers and different IP ranges and stuff. So it made some of that some of those services more popular. But yeah, that's basically where it started, was spammers. And then, like you said, once Bitcoin started to take off and it was worth money, people realized, hey, look, we can rent these servers, and we can rent pretty large, beefy servers with 8 cores and 64 gigs of RAM, and so what if we just spin up a bunch of these? And normally that would cost you money, but if you stole somebody's AWS key, they're going to get the bill, not you. So, they would basically take the key and spin up a ton of servers and just have them mine Bitcoin all day. That's kind of died off a lot because as Bitcoin got more popular, the difficulty for hashing went up, and CPU mining and even GPU mining is really no longer useful.
Yeah, definitely not as lucrative as it could be. So just for our folks live watching, we've thrown on Twitter the links to Daniel's blog. So I suggest jumping on it. We'll be doing several references. We'll also do a screen capturing for folks to be able to, reference this at a later date. But if you want to play as we go or have any questions about some of the techniques we don't cover that Daniel mentions, feel free to hit us up. This is a live show intended for folks to ask live questions. So
yeah, and if you like this and you want to give props to Daniel, you can find him on Twitter. He is at DAGRZ.
Cool. Now that we've done that, Chris, where do you want to take this episode? Well, there's a lot of places, right? We can talk about theoretical, how to initially gain access. We could talk about, or we can just assume that somehow the attackers already got the AWS keys to the kingdom.
Well, so we already covered some of it. Like where, how does an attacker compromise one of these AWS accounts? And you talked about it a little bit. Checking in keys. There's actually a lot of stuff you can find in configurations that people accidentally check into their personal repos on GitHub. And if those repos are public, people mine those. I've seen it happen not just with AWS, but I've seen it happen with like WordPress blogs and stuff. I've seen people accidentally upload keys to third-party services, things like Stripe, things like PayPal, API keys to all these services that people put in configuration files that they accidentally check into their repository. So that's probably the biggest way that people find these. I think I saw some research somewhere where somebody just trying to figure out how long it would take. They made a repo, they uploaded some AWS keys, and I don't remember the exact number, but it was within minutes. Somebody had already taken the keys and was already compromised the account and was using them. So, I mean, it is very quick. Like if you upload them, you're in trouble.
Yeah, there's no doubt. And although I can't speak on the record here, more than once have I heard kind of a two-pack, or maybe a 1-2 punch for an actual compromise where a company was owned. On top of it, by the time that they actually discovered they were owned, folks had went and resold some of the data from the compromise, which include their Amazon keys. So the original attacker not only had done damage, made away with some of the internal treasure trove from the internal network, they had then, resold the keys to AWS accounts, which, that's terrible, right? It's somebody kicking you while you're down. But even that, I've heard of folks, and I don't know if it happens the same way anymore, but good old password reuse. Did we touch that one already?
No.
Like people just using the same credentials in other services, or administrators using shared creds and the same credentials from a POP service, or somebody who had hashes disclosed, or heaven forbid clear text, passwords exposed, and being able to reuse it in other places. More than once have I heard of Amazon coming to the rescue when they had detected, we had detected your username and password was used over here or disclosed over here, and actually contacting the companies and saying, we know that you've reused the same password. As a result, we've temporarily disabled access to your account to protect you.
Right. Yeah. I mean, it seems like every month there's a new password dump from some service that got hacked, and immediately people are taking those and they're trying. If it's clear text, they're going to go try those on services. They're going to try and crack the hashes if they're not salted and stuff. So I mean, something that the security industry has been saying for a long time is like, don't reuse passwords. Make a unique password for every place. So yeah, that's definitely another method. But you touched on something that I think we should get into a little bit, and that's you were talking about stealing the data once they get in. So I kind of wanted to touch on what are they looking for when they get in? I mean, really, the first thing that they're going to want to do, like a good attacker is going to do, is disable logging. So there's a service in Amazon called Cloud Trail that kind of logs everything that's done. So every time you spin up like a new EC2 instance, which is basically just like a virtual machine, anytime you create a new account that can access thing, all of that is going to be logged. So like the first thing they're going to do is like turn off logging. But once they do that, then they're going to be looking for really ways to monetize this. So now that Bitcoin and stuff is no longer really useful, they're going to be looking for your database. They're going to want to steal any information that you have, credentials. They're going to want to go sell that. They're going to be looking for like third-party services that you use. Like say your site uses Stripe for credit card processing, right? They're going to go and try and find your Stripe keys and see if they can transfer money to an account. Steal your money. Really, they're looking to like just monetize this, as best they can.
So Chris, you've definitely engineered a lot of things, built a lot of products on top of AWS. If you were, to essentially have somebody gain keys to your castle, whatever, you made a mistake, you uploaded your creds somewhere, maybe you had it on a USB drive and it was misplaced or something along those lines. What would keep you up at night? And, are there any things that you can think, maybe whether it's architecture design issues or something along those lines that could have made a difference? I know that might be jumping the gun a little bit here, but I definitely want to frame, maybe the realistic side of the house of what could actually happen. I'm sure some of our viewers host their stuff on AWS, and maybe the thing they're really thinking about is, how can this not happen to me? Or when it does happen to me, how can I minimize the impact?
Right. So one of the things that you want to use, which came out in the last couple of years, and Amazon's really pushing for this, is their IAM service. So when I first started building with Amazon, it was just like you made an account and you got keys, and like your key could literally do anything, right? Like it was the God key, it was root, right? It would be like if you logged into your box as root just to browse the internet, right? A bad idea. So they created IAM, which allows you to generate sub keys, and you can make those keys very specific. Like, so say you had a web app that needed to store files on Amazon's like storage servers, you could make a key that only had permissions to do that. So what you definitely want to do is figure out like, okay, I have this service that needs to interact with these other Amazon services. What's the minimum amount of permissions that I can give here, and generate keys for that? That allows you to easily revoke them. If your servers pop, you can revoke those keys while still maintaining other keys for your developers, for your engineers. Just try and, like any good network, you try and segment it off and put checks and stuff in there.
Yeah, it sounds like least privilege in action, right?
Yes, absolutely.
If you have something, I don't know, some type of module or something along those lines that needs to pull a database, maybe it has no, rhyme or reason for that to have access to some secondary backup or something like that you're also storing in the cloud. Segmenting those roles sounds like common, but if it's not implemented, what's going to stop somebody from moving laterally?
Right. So one of the things that I actually thought was really interesting about Daniel's blog post is he kind of touched on some stuff that I don't think too many other people have touched on. A lot of other people focus on like smash and grab. Once you get these AWS keys, how do you just immediately harvest it for whatever data you can and then just burn the whole thing down, really? What he was talking about was like, how do you backdoor this AWS account so that you can like maintain your access over a long period of time? That way you can siphon off more data. You can maybe get in the middle of their credit card processing, steal credit card information, whatever you want to do, you can maintain access for like a long time. So how can attackers do that? And some of the ways were kind of interesting. So he talked about generating temporary AWS keys. So you can generate an AWS key that lasts anywhere from like a couple of minutes up to like 36 hours, I think is the max. So he talked about like setting up a cron job that would just every so many hours refresh those keys and get you new keys. And one of the benefits to this is if somebody identifies that, oops, we checked in this key into our GitHub, let's revoke that key, your temporary key will still work. So you could have up to 36 hours still of maintaining access, even after they have removed or disabled that key that they realized they exposed. So as an attacker, there's a benefit to that. As a defender, something to keep in mind. Whereas like there might still be temporary keys out there, so you got to watch for those. And I think there's a way to revoke those, but I don't know off the top of my head how to list all the current keys. And I think that's actually something Daniel talks about is a limiting factor for AWS is you can't say show me all the temporary keys or the sessions that exist.
Yeah, I can imagine. I mean, we talk a lot about the pen testing engagements, which last 3 days, a week, whatever, some short duration of time. But I think the reality is most actual compromises, well orchestrated, somebody who's taken their time moving through the data. I mean, 36 hours isn't a whole lot of time. And on top of it, even if you had set up some type of 36-hour window that limited me of how long this key was good for, I know you would surely throw me for a loop if in the middle of the engagement, all of a sudden I lose all my access. I mean, to be honest, I'd probably just assume like, oh, you must have caught me. Maybe I need to start backing out, or maybe I need to go backwards. If I wasn't familiar enough that, hey, some of these pieces of infrastructure are in place, let alone if you actually like set your, the keys at a timeout in 15 minutes or something like that. I mean, that would almost make it impossible for me to, truly take advantage, or I'd have to game around that, develop around a solution around that handles this constant dropping of access.
Right. Yeah. So let's say you're a defender and you get popped. Like, how do you make sure that your account is clean? How do you clean it up and remove the attacker? I looked into this a little bit, and like Kyle said, I've done a good bit of engineering on AWS and set up a lot of stuff, but I am by no means an AWS expert. There's a lot of different services that are specific to things, and there's actually just a lot of functionality for AWS that I just have never touched. But what seems pretty clear to me is that it's very hard to actually get your account and say like, this is clean, like there's no attackers here. There's just so many different services you can set up and so many ways that you can generate more keys, or you could actually, an attacker could migrate from actually the AWS account to the virtual servers, and they could just install malware on those servers. So, it might be worth like refreshing your servers to clear out anything that, could have been added there. So like that kind of stuff is difficult. From what I understand, AWS, like if you get in touch with their like customer support for like security, they can give you lists to say, go look at these things and like, here's how you can try and clean this stuff up. But it doesn't seem to be super easy.
Yeah, and if you're the IT staff or, the web engineer that's behind, setting up whatever cloud service that's offered to you, and think about the onus that's going to be on you if your cloud setup gets compromised. Somebody's going to say, hey, do you feel confident that your AWS instance is clean? And I personally, I would not want to be in that role. I'm not qualified enough. I don't know enough about AWS, despite spinning up numerous VMs. I'd be able to identify like a loud and proud hacker that came through there and just like, I'm going to create an alternate username and an alternate key. Yeah, I'd find that. But if somebody decided to maybe even spin up another VM, if I truly had enough VMs running in my AWS instances, and they followed my naming scheme and I wasn't super diligent, I could see them just hiding in plain sight. And maybe that's enough for, to keep me working, let alone giving my management the thumbs up. All right, we're okay to start processing credit card information again, or, we're safe. We're not going to get defaced, or they're not going to steal our additional data. I wouldn't want to be in that situation.
Right. Yeah. I mean, if you are compromised, I think the only smart thing to do is to call in, security response company. At this point in time, AWS is popular enough companies are using it. They should definitely have somebody on staff who's familiar enough with AWS to say, okay, these are all of the places we need to look. This is how attackers do this. This is how attackers maintain persistence. So we need to clean this, and this. So, if you are ever compromised, just roll incident response, and some of the onus will be on them then.
So, Chris, I'm reading, as we go. Oftentimes we find little bits that stand out to us, during the middle of an episode when we just have so much content. And some of the stuff that's sticking out to me right now is just the even more subtle. Maybe if you had automated infrastructure to provision your AWS accounts, like if somebody actually went through there and had adjusted the scripts that you use to programmatically, either spin up new infrastructure, or maybe you have something like, maybe you just want to handle load, load distribution. You automatically spin up new VMs or wind them down as load increases. It would be hard for somebody, instead of just, going and, defacing something, to say, all right, under this scenario, why don't you spin me up my new command and control server that's provisioned this way? Or maybe you upload my scripts, or upload this role somewhere in AWS, and it's only accessible in the hours of 3 a.m. to 5 a.m. when nobody's usually looking at it.
Yeah.
All right.
Yeah. A lot of that stuff is, like I said, it's difficult because, like AWS gives you the ability to spin these things up, but and they have some services that provide you a lot of that automation, like things like Elastic Beanstalk and stuff. But a lot of people have rolled their own with like a cloud formation and templates and stuff like that. So as complicated as it gets, like I can only imagine. I've never seen like a Reddit's infrastructure and how many servers they have and how all the pieces talk to each other. But I've got to imagine there's a ton of like automated scripts and events that fire that cause new servers to be spun up and stuff. Oh boy, that to me, that's a nightmare, just to try and figure out like all of the stuff that could happen, or or even like Netflix uses AWS. Like imagine their setup. They've got stuff constantly going on. So to me, that's a nightmare.
Oh goodness, some funny stuff in here. I know we're using humor to kind of touch on some of these topics. I think this really reiterates, if your job is the AWS engineer, you need to know it inside and out. Even as a junior AWS engineer, who do you think is going to get called when even the security team spins up? I've been at InfoSec for years, done tons of engagements. I would not be qualified at all to handle a proper incident response effort on AWS, despite being part of incident response efforts for years. So I think, if anything, Chris, we might see, maybe people will seize the opportunity to specialize in it. Are you aware of any service? I didn't even look, but anybody who specializes in incident response on any type of cloud service, Azure, AWS, whatever.
I didn't look, but I'm sure there are. Going forward, more and more stuff is being moved to the cloud as, people realize the benefits of not having to buy your own servers, refresh the servers, being able to scale up and scale down at any given time. So with more and more stuff moving to services like AWS and Azure and Google App Engine and stuff like that, if you're in security and you want to, make yourself relevant in the next 5-10 years, definitely look into this kind of stuff. There's plenty of places that would hire you, just based on your knowledge of AWS and the security of it and stuff.
Yeah, I definitely think it's a neat niche and definitely unaddressed, right? You've got 10,000 people who know reversing in the Windows side of the house, or incident response in the Windows side of the house.
Yeah.
You think about AWS, all those skills matter, but it's an extra layer of services that I'm sure most of us couldn't touch, or we'd have to spin up on before we'd even be qualified.
Right.
So Chris, this is about the time of the episode where I think we should maybe open it up for questions. We've got both the live chat. I'm sitting here monitoring Twitter as well as we speak here, guys. So if you do have any questions, I would encourage any single one of you guys to hit us up. Let us know. Maybe we're off base. Maybe you've seen a scenario that we haven't. We just real briefly talked about where you could compromise and how you could harden. Most of them probably sounded like best practices. So please chime in. Let us know what you think. And Chris, while we wait for that, are there any other links we need to pass on? I did want to show one real quick, if you don't mind.
Yeah, go for it.
So this was earlier we referenced about AWS keys going on GitHub and just how quickly things get out of control. So I'm sharing this to everybody here real quick. This is Dev puts AWS keys on GitHub, then bad things happen. I'll save you the reading real quick, but if you take a look, just the first two sentences, I see about a a $2,300 bill here, $2,400 bill. And on top of it, I see a quote, I only had S3 keys on my GitHub and they were gone within 5 minutes. I know Amazon has done a lot of work and GitHub has done a lot of work to prevent these type of things from going live on their servers, but they're not perfect. And there's a lot of other places than GitHub to put, your keys accidentally. You could FTP them somewhere. You could throw them in numerous amounts, maybe Google Drive, and you just didn't have permissions set up properly. So I did want to share that. People are obviously leveraging these techniques, and they have it fully automated. That's the only way that this 5-minute compromise, could have possibly happened. So,
yeah. If you Google for this kind of stuff, AW account hijacking, AWS compromise, you'll find a number of blogs, a number of forum posts. This happens actually more than I think people realize. And usually Amazon is pretty good about it. And if they can identify that, this probably wasn't you, this was probably malicious, usually they will just nullify those charges on your bill. But you don't want to have to deal with that if you don't have to. So one of the things we haven't really talked about is there are a number of tools to help you kind of avoid this. Some of them they hook into Git. So when you do a Git commit, basically you can add some scripts that are called hooks. And so people have written a number of scripts that will look at what you're committing and try and identify if there's AWS keys or Stripe keys or third-party service keys in there. And so before you end up pushing it to GitHub or making it public somewhere, it will notify you and say, hey, I don't think you want these in there, and then you can go through the process of getting them back out. So if you're a developer, it only takes 20 minutes to set that kind of stuff up. I definitely would take advantage of things like that, just as another protection, so that you don't end up with a $6,000 AWS bill.
Yeah. From that blog that I posted, the happy note was they did refund it, but I'm sure that's more time than anybody wants to deal with. I do want to post on here, Amazon's pretty decent about their documentation. And just while us chatting here in this conversation, I found AWS security audit guidelines. When you should perform an audit, how do you review your groups, your roles, mobile apps, they've at least thought of a lot of these. And I imagine it's because they're dealing with security incidents all the time from customers worldwide. So you've never looked at the general guidance. I mean, we'll tweet the darn thing out, but it's one Google away saying, hey, what are the security audit guidelines for AWS, and learn from their examples. Reviewing your credentials. It's everything that we touched today, Chris. So I think good on you for some of the research that you put in earlier.
I don't see any other questions. Do you see any questions?
I had some folks mention that they direct messaged me and pretty much said, hey, glad to have the episode back. Some folks said, hey, we need to do maybe a better notice on these episodes, but so far I don't see anything, so I'm going to take it. We've at least done an adequate job about exposing, hey, AWS can be compromised. Any web service can be compromised. You really need to know your stuff, because if you're doing incident response or even just administration of the system, I think the onus is going to fall on you for being the master of that domain to say, hey, is this thing good to go?
Yep. Cool. Well, I think that's going to do it for this week's episode of Tradecraft Tuesday. Thanks for watching. If you like it, subscribe on YouTube. That should get you some announcements of when we create, when we schedule these. Also, you can follow us on Twitter. We always post to Twitter when we schedule these. So, yeah. Do you have anything else?
I don't. I just mentioned to the folks that were chatting on here, if you guys haven't jumped on to our Slack is invite-based. We set up a real simple service on Hamsterpad. We tweet it all the time. So if you haven't had an invite accepted to get onto our Slack page, you can always send us a DM. I can't imagine either one of us can't get a hold, or you folks can't get a hold of either one of us to get an invite. So let us know if you want that invite and haven't been invited in the past.
Cool. All right. Well, I'm Chris Bisnet. It's Kyle Hanselman. This has been an episode of Tradecraft Tuesday. Hope to see you next week. Later.